Okay. Tanuj built his gearbox backwards. Genie built their gearbox sideways for no particular reason other than to annoy me. Notice any major differences? Okay, well, I notice Tanuj and Aiden are in the channel, so if you all can type a 1, 2, 3 in the chat, if you can hear me, or just unmute your mic and say hi. Yes, Alex, we could hear you. That would be fantastic. Try and throw this water bottle into my recycle bin. Missed. Greetings, Aiden and Tanuj. How are you both doing today?
Good, how are you?
Doing pretty good. Got my second COVID shot today, so I'm seeing if I get any side effects. I haven't felt any yet, but we'll see. I am streaming on Twitch, so go ahead and log on to that and make sure you could see my screen and hear me and everything. I just put a quick announcement into the channel. So, Aiden, can you confirm that you could hear me on Twitch? Okay, cool. Tanuj, you confirm that you can hear me. Okay, cool. So both of you can hear me. Awesome. I'll wait a minute or two to see if Angini or Shrethi or someone else joins us. Um, just looking at where you all are today. Um, both of you all seem to be caught up to the same point I'm at. Um, I'm just kind of going between these three views. I can't notice anything major. The only changes I would make, Aiden, is here. You don't have this lower bar connecting this kind of lower guardrail here. Um, while like this one that I have right here, I would probably model that just because realistically thinking about CNC in this bar, um, that's a lot of distance without any sort of support to the main structure. That's just going to be less flexible. It's less likely to be clean when it comes out of the CNC. It's just overall not great to have that much area on not support. So nothing major. It's just something I noticed. Um, and Tanuj, if you ever get annoyed by these icons, the mate icons, if you press K on your keyboard, that just makes them turn on and off. Or if you press J, same thing happens with both of them. So K and J, turn those off. I just like keeping them off because they annoy me. Okay. Well, I guess we will go ahead and get started. First, do either of you have questions from where we left off 2 weeks ago? Ah, there's Shrethi. Um, so Shrethi, if you can confirm you can also hear me on the Twitch live stream, that would be great. Everyone looks like they are. Okay, so I assume none of you have questions. Feel free to speak up if you do have them. One other thing I noticed quickly from both you, Tanuj and Aiden, you all used the 72 tooth pocketed aluminum gear, um, while I used the 72 tooth steel gear. Um, doesn't matter. The CAD models are identical, but just if we were actually CADing a robot that we were building, we would want to use the component that we'd actually design into the robot. And as I mentioned last week, I prefer using all steel gears just because your steel gears are not going to wear down as much as your aluminum gears. And so if you're going to use steel gears in your robot, you might as well put steel gears in your CAD model because worst comes to worst, someone goes to your CAD model, pulls the bill of materials, and says, "Oh, we need to buy an aluminum gear." It's like, no, we actually needed a steel gear. So um, that might be one minor thing to change. Otherwise, everything looks great. All of y'all's gearboxes look basically identical, other than minor things. I recommend quickly doing an interference check just to see if there's any major issues with your gearboxes. Oh, Shrethi, hi. Sorry, where are we? We're just getting started. So we're in the Onshape documents. I was just looking at all of y'all's documents. Um, so just open up your own document and follow along here. Um, so again, let's quickly run an interference check. The way you do that is you go to your assembly, click in the upper most instance on the left side instance panel. Click on that so you're highlighting everything. Right click on it and hit check interference. And just look around to see if there's any major interferences. Interferences are shown in red here. And you're always going to have some interferences. That's kind of unavoidable, but you have to think, is this an interference that matters? So in this case, I'm getting some interference between my big spur gear and my little pinion gears. But I know that doesn't matter because I didn't really model in the, as you can see, I could twist these gears. I didn't model in them, so they mesh perfectly. I know they mesh perfectly, but I didn't bother actually CADing that. It's a little bit of a pain if you want the teeth to mesh. Um, I should probably double check the distance, the center distance of those, but that's just kind of the thing where you'll always see interferences. Kanush, is there a steel 72th pocketed gear in MKCAD? Because I can't find one. There should be. Let me check MKCAD quickly. Gears. Gears 70. Huh. That's weird. I do not actually see one in MKCAD either. Where did I pull this from? I might have accidentally pulled this from a different source. Oh, wait. Let's check one thing quickly. They might not actually have steel gears that size. Let us check gears on West Coast products. Pocketed gears, I guess. Aluminum, steel. Okay, I lied. There are no steel 72 tooth gears, so we have to use aluminum. My bad. Ignore what I said earlier. I really wish they made larger steel gears, but I guess they don't. You don't get as high of teeth loading on larger gear sets, just because larger gears tend to have less torque on them. So I guess they don't feel the need to make steel gears of that size, but I would do it anyways because they're gonna wear down. Okay, so we got a lot done last time, but let's continue. I really want to get to the point on today where we are starting to actually assemble the frame of the drivetrain. If we could get the drivetrain frame done today, I would be very happy. So let's start moving through that. I am going to put a little block up here in my tabs so I know which tabs I'm working on. Okay, so let us go into the 1678 robot and let's see what we need to do next. If it's ever going to load. Hopefully my internet didn't crash. I don't think it did, no. My internet might crash today. I've been trying to stream the past few days, just general solar car 3D printer stuff, but my internet keeps crashing, so it makes it very frustrating. So I'm gonna go down here. I'm gonna zoom into the drivetrain. Actually, let's go here. Let's go to their drivetrain assembly. Okay, cool. So there's a few changes that we need to make to the gearboxes before we continue. First and foremost, the gearboxes we designed aren't actually completely realistic because I've mentioned this a few weeks back, but we need to add fillets to all the corners. Shrethi says, I have an interference with my spur gear and I don't know how to fix it. Let me just check here quickly. I'm going to do an interference check. Ah, I see. So this is actually a good example. You have this big interference here in the middle, and this is the type of interferences you want to worry about. So it looks like to me you're having some issues with your hex shaft being tilted at a 90-degree angle, or not even a 90-degree angle, at like a, what is it, 30-degree angle. So that's causing these little pyramids. But then it also looks like you're having an issue with maybe your bearing. I can't quite see what that is, but that might be your bearing conflicting with the rest of your gearbox. Let's actually get in here and see. And one easy way to check this is if you right click on a part and make it transparent, you could get in and see what might the actual issue be. So I see that the bearing is going in here, and I'm thinking that possibly the bearing diameter might be larger than the hole that you're putting it into. So I'm going to click on the outside of this bearing, and that has a diameter of 1.124 inches. It's just under 1/8 of an inch. Now let us hide the bearing quickly. Hide bearing. And let us grab the outer diameter of this hole. hole itself also seems to be 1.124 inches, so that doesn't seem to be the issue. Now that I'm hiding that piece, let's run another interference check. So it doesn't seem to be the bearing. The bearing's too far back. It's something here in the middle. So let's hide your sprocket gears quickly. Hide that. Ah, I see what the issue is. Your sprocket gear, if I hover over it, you can see the outline of it. The outline of your sprocket gear is actually, of your sprocket is going into your gear itself. So notice that here, you can see the end of the sprocket is actually going into the gear. So if I hide that, that's what the issue was. You were covering up this part of your pocket, your pocketed gear. Sorry, I can't use words right now. So that is a mating issue. So what you need to do is you need to fix the mate for this sprocket gear. And an easy way to do that is if you find the part that is your issue, you right click on it and you hit show mates. It will actually unhide the mate down here in your mate features. And you could find which of the two that might be the issue. So I'm assuming it's going to be this first one. You just have to make sure your mate connectors are correct. Yep, Tanuj got it. So that's a pretty easy fix, and that's part of the great thing about having your mate features be named is you can very easily go in here and find out what the issue is going to be. If you just had fasten 1, fasten 2, fasten 3, Revolut 1, Revolut 2, Revolut 3, it sometimes gets very confusing. Most of the times, I don't even need to show the mate features. You could just go down into the mate features and find out which one's the issue. Okay, so I'm gonna let you fix that, and in the meantime, we're gonna go continue working on some of these parts. So I'm gonna go back to the drivetrain part studio, and I'm gonna pull up drivetrain part 001, the main gearbox plate, one with all the Pokeball looking things. And as I said in previous weeks, if you're gonna CNC this out, when you actually go through the process of CNCing stuff, God, that's hard to say. You can't create perfect corners because if you think about taking a round bit and kind of shoveling out material using a circular bit, you're gonna create a circular path. So anywhere that you have a kind of sharp corner, like here, that's just not realistic. You can't do that unless you had like a really, really, really tiny bit. That's the only case in which you could, make a sharper corner. But even then, it's still going to be rounded slightly. So the way we fix this, and we have to fix it because if you were to actually take this and throw it into a CAM program like Mastercam or Fusion 360, it's going to spit out errors. It's going to say you do not have the tool available to make this toolpath. So we're going to fix this by adding fillets everywhere. And fillets, as you all probably know, just kind of round out a corner to a certain radius. Now we could manually add fillets to every single corner, and I've done that before, and it's a huge pain. Thankfully, I found a really cool feature script that I linked to yesterday called Fillet All Edges. It's from Julia's feature scripts. So I linked this in the Discord yesterday. So if you haven't added this, make sure you go use it. It is the post before the one I put today in the general chat. Just go to this Chief Delphi link, click on the link, and then there should be somewhere on here that allows you to add features. Kind of forget how you do it. Let me look at. I think it has instructions on here. Oh wait, no, I think I remember how you do it. I think you have to go up here in your own workspace. You go up here to the rightmost thing where it says add custom feature scripts, and then you paste the link from Julia's feature scripts, the link they have in the Chief Delphi post, and you just paste the URL there, and it will allow you to add the feature scripts from this document. So go through, add all of the feature scripts just so you can have them all available on your toolbar. And the one we're specifically going to use is the fillet all edges. So I'll demonstrate this quickly, and I'll demonstrate it a few times. But if I click fillet all edges, and then I click on the front face of the document, I'm going to click right here, it's going to go through and fillet every single edge. Now, there's a key thing that I learned yesterday. In our situation, it actually throws an error because there are some situations where you can't actually apply a fillet. For example, down here, where you have two edges very, very close to each other, Onshape doesn't like that. It says if you have two fillets that overlap, it throws out an error. So what you actually have to do is you have to go to the exclude button, and you have to exclude at least one of these very close edges. So I'm going to go through here and just kind of exclude some of these edges that appear really, really close together. And in our case, there's 6 of them. You'll notice as soon as I exclude those 6 edges, it allows me to add fillets everywhere else. And I'm going to add a fillet radius of 0.125 or 1/8 of an inch. That's assuming we're using like a 1/4 inch bit. Really doesn't matter what size bit we're going to use. It's kind of up to the discretion of Mr. Schneider or anyone operating the CNC mill. But I'm going to assume that we're using a 1/4 inch bit here. I'm going to hit OK. And as you can see, every single edge along here has been filleted. So now it's a lot smoother. Now, I'll cover over this again. So if any of you are confused about exactly what you do, I'll demonstrate how to do it again. But notice that those edges that we excluded, those are still there, and those are still really sharp. So in this case, what we actually want to do is we want to apply a second instance of the fillet all edges. We go through here, and we're going to fillet all edges again. And now there are no other edges except for the 6 that I've already removed. So what this is going to do is this is going to apply an additional fillet to those certain areas. And if I hit OK again, you'll notice that it fills in those areas really nicely. So now this is a part that you could actually CNC. So I could take this, download it, upload it to Mastercam, and then run the CNC mill and actually get this part really, really quick. And I could do it without having to manually apply like 100 or so fillets, which is a huge pain that I've had to experience before. So I'm going to demonstrate how to do that all very quickly again. So if you missed it before, I'll show you how to do it one last time. Okay, go to the fillet all edges tool that you imported as a custom feature from Julia's feature scripts, which are linked in Discord. Okay, click on the face. I'm going to go to exclude, and I'm going to exclude at one, not both, but one of the edges where you see 2 edges appear really, really close to each other. So in our case, basically around this center circle on our gearbox, you're going to exclude one of those edges. Exclude one of all of these guys that are really, really close together. It doesn't matter which one. As soon as I do that, it's going to allow me to apply fillets everywhere else. Again, I have an 1/8 of an inch radius. I'm going to go up here. I'm going to fillet all edges again. So now I filleted all edges twice. I'm going to select both of those, and I'm going to throw them up into the folder with the rest of the gearbox plate things. So I could keep everything in my part studio nice and organized. There's another interesting. Oh wait, can't you just highlight everything? Yeah. I think that'll make the top and bottom not flat. You might be right. I'm not sure what you mean by highlight everything. You mean like both of those close together edges? I mean, you can experiment with this yourself. If I suppress both of these, and I try applying like a fillet here, like apply a fillet up here, then if I try applying a fillet down here, Onshape says failed to fillet sections. Now, if I made the fillet a lot smaller, you can notice that like I can have two really small fillets, but as soon as they come together a little bit too much, they become errors. I can have a fillet like that of like fifth of an inch, or 1/500th. No, wait, what is that? 5/100ths of an inch. But that would require a really, really tiny tool. So I just want to apply 2 instances of the fillet. Do it once and then do it again. Unsuppress those. Okay, so I filleted everything. Now, one cool thing that you could do here, and this comes into team organization and management when you're actually building robots and you want to organize everything together. Hold on. Okay, yeah, sorry, it's just reading chat. Um, One of the things that you want to do, if we're thinking about building robots really efficiently during the season, what you want someone to do on the mechanical team is you want them to go to your robot or your assembly. Say they come in here to your gearbox assembly and they want to pull up the bill of materials. And you want someone who is on the mechanical subteam or say on the fabrication subteam to be able to build your CAD model without ever talking to a CAD member. All of the information should be stored in Onshape. And so, in a situation like this, where we are saying as CAD members, we are making the decision that this part must be made with a 1/4 inch CNC like bit or smaller, we want to document that because let's say someone pulled this CAD model and they went to the CNC mill and they used a 3/8 inch bit or they used a 1/2 inch bit and they tried milling out this part with a 1/2 inch bit and then it would throw errors and they would have to come over and be like, yo, Aiden, why can't I CNC this part? And you're like, oh, because you need to use a 1/4 inch bit. How do they know that? There's a cool thing that I found out is if you right click on your parts down here in your parts list and you go to properties, we've messed with edit appearance and we've messed with assign material, but you can actually go up here to properties and you can add information here. So like for example, here in the description, I could say all fillets are 0.125 inches. Use 1/4 inch CNC bit or smaller. And I could hit apply and save. And so if someone were going in here and let's say we use a bill of materials manager, you notice now in the description it has that information attached to it. Or if you were to make a drawing of this part, you can attach that information to that drawing and hand that drawing off to someone. So now that information that you decided as a robot designer, as the CAD person, is now permanently attached to that part. And so now no one can complain if they didn't know anything because you have attached that information, those decisions you've made to the part. That's something very useful that I'm sure will come up later, especially when we get to making robots during the season again. So we're going to do that same thing that we just did to this second gearbox plate. We're going to fillet all edges one more time. So we're going to pull up drivetrain part 002. And we are going to fillet all edges. Click here. As you see, we don't have any errors. So make sure again, 1/8 of an inch radius. Done. Boom. So that's all done and good. So now if we go back to our gearbox, we notice that all of our parts have nice rounded edges. So this could be very easily CNC'd. So we're all good on that front. So let us look at what else needs to be done on this gearbox before we can move on to the actual drivetrain itself. The last major thing on the gearbox appears to be these things.